Let's see how to build bisulfite in WebMO. Let's start a new job. When you begin a new job, you'll pull up a Java applet, so you'll have to give the permission to your computer to allow the molecule builder to fire up. We'll begin by selecting sulfur in the periodic table. Choose sulfur and click in the builder screen. Now let's add some oxygen atoms. Let's do the structure that has 3 oxygen atoms only bound to sulfur. So there'll be a double bond. Just draw the line twice and then continue on with the 2 sulfur-oxygen single bonds. Now let's add the hydrogen atom. Let's attach it to the oxygen atom. So click on hydrogen in the periodic table and go ahead and make the connection between oxygen and hydrogen. Now let's add charge to the other atom, -1. So right click on that atom, charge, and in that box go ahead and put -1. If you apply that, you'll see that the charge shows up on the atom. Click OK to accept that. And now we have the structure, but it's really not acceptable if you use the rotate tool. We don't ever want to start doing a geometric optimization from a planar molecule because the computer is likely to get fooled. It's going to trap it in what is a local minimum. So let's distort the structure a little bit just so that we begin from a geometry that the computer can adapt better. So select one atom using the select tool and then translate selection just by dragging that down. And now we've distorted it away from planarity. Let's choose the other oxygen. Also translate that selection by dragging it down to make the pyramidal sulfur molecule. Let's rotate that so we can see that it's pyramidal. And now let's do the geometric optimization. So to do that, we need to go on to the next screen. And that pulls up a menu item so that we are going to choose MOPAC as the computational engine. It's a relatively quick computation. We now need to tell it what kind of computation to do. The calculation we want to do is a geometric optimization so that we can find the ideal geometry. Go ahead and begin the job by going on to the next screen and you'll be back to the WebMO Job Manager. You can see our job is in the queue. This shouldn't take too long, especially since we're right on top of the queue and it's complete in just a very short period of time. Go ahead and click on the job. It doesn't look like anything has changed when you first view the structure. It'll show up in very much after we permit the applet to load. It's going to show up in exactly the same way we left it. But you'll notice if you scroll down that, so let's rotate it a little bit. Now let's scroll down. You'll notice that there's a geometry sequence, and each of these are steps in the geometry optimization and the energy that corresponds to it. And so there were 37 steps of geometric optimization in that calculation that took place in that very short period of time. We can animate through those steps, and we can see what the computer was doing as it was optimizing the geometry, trying to find the minimum energy. And there it found it in step 37, and you can see it has a nice symmetrical shape to it. And if we go ahead and do some measurements by clicking on the selection tool, hold the shift key down and select 2 atoms and you'll get the bond length. Select another 2 atoms and we'll see that those 2 sulfur-oxygen atoms are the same bond distance, but the third sulfur-oxygen bond distance is quite a bit longer. Hold the shift key and select 3 atoms and you'll see the bond angle. And so we can get all the geometry of this optimized structure. Again, this is the lowest energy structure. If you go down, the negative values get larger and larger, more and more negative, reflecting a lower energy.